Good day, Doctor. We are from Group 4 and we are going to present a proposal of open-ended lab on the double effect evaporator. The problem statement of this experiment is to determine the optimum cooling water flow rate and its optimum temperature for concentrating the solution of syrup to 70% weight per weight. There are two objectives for this experiment. Firstly is to investigate the effects of cooling water flow rate and temperature upon the concentration of syrup and acid of evaporator. The second objective is to compare the performance of double effect evaporator with the single effect evaporator under the same factors. The manipulated variable is the cooling water flow rate and also the cooling water temperature. For the responding variable is the concentration of syrup and the acid of evaporator. And last, the constant variable is the volume of syrup solution and also the steam pressure.
The slide discusses about the complete procedure of the cooling water temperature. The cooling water is turned on and filled with the first effect to the center of the middle observation pot and is heated. When the water achieves 25 degrees Celsius in the first effect, the syrup solution is introduced into the first effect of the double effect evaporator. The steam generated in the second effect is used to heat up the syrup solution. By using a refractometer, the concentration of the syrup solution from the second effect is recorded. Steps 1 and 2 are repeated using different cooling water temperature of 30 degrees and 35 degrees Celsius, while the other operating conditions are kept the same. A graph of concentration of syrup solution versus cooling water temperature is plotted. The performance of the system with single effect evaporator under same operating condition is compared and contrasted. For the cooling water flow rates, it's basically the same with the cooling water temperatures, just that we need to repeat the experiment with different flow rate of 70, 75, 80, 85, and 90 kg per second. The graph of concentration of syrup solution versus cooling water flow rates is plotted.
Next, I will present the data table of this experiment. The first operating condition is the cooling water temperature. The following shows the data table and the graph of concentration of syrup against cooling water temperature. Both experiments of single and double effect will be operated under the same conditions to compare their performance. The second operating condition is the cooling water flow rate. The following shows the data table and the graph of concentration of syrup against cooling water flow rate. Again, both experiments of single and double effect will be operated under the same condition, which use the same cooling water flow rate to compare their performance.
So now I would like to explain on the safety precautions of the experiment. So first, do not touch the valves with bare hands, as there are some process valves that directly discharge the steam into the air. Close the header valve immediately if the evaporator above the top view port is overfed. Ensure that no person is standing under the second floor when opening the valve to avoid the liquid being discharged onto the person. Ensure that the cooling water is enabled to flow before the experiment, and it is only turned off after the stop of boiling process. So that's all from us. Thank you.